Okay, so we're going to look at this booklet on straight line kinematics. It will take almost all of the period, so I'll try to get going as fast as I can here. Sure, if that's what you prefer. Any study in physics is best approach. Time to engage the brain, right? Time to focus on this. Time to put the cell phone away, the earbuds away, the mini-wheats away, and actually focus on what I'm saying. It will go a long way. Any study in physics is best approached by beginning with the simplest part of the concept, followed by adding complexities as each step is understood. Concept of motion and its analysis is fundamental to physics. Consequently, we will begin our study with this concept. Philosophers and scientists since the beginning of time have observed and speculated on the nature of motion, but interestingly, the concepts they developed for approximately 2,000 years until Galileo's time were unfortunately completely incorrect. Aristotle had all these bright ideas about motion, but he never actually did any experiments, and everyone just said, oh yeah, you're Aristotle, you must know. And we were wrong for 2,000 years. We as in humans. Our study of motion will begin by analyzing it in its simplest form. By analyzing motion alone without being concerned about its cause, that's called kinematics. You may remember what the other one is when we talk about the forces involved. Starts with an M, and it's a place where you take your car. Mechanics. Mechanics is when you deal with forces. So, kinematics. This is called straight line kinematics. In order to study straight line kinematics most effectively, we will look at the simplest concept first and use them to develop more complex ones. An easy way to picture straight line kinematics is to use a train as an analogy, because its motion is restricted to tracks, and for our purposes, we can assume that the tracks are always in a straight line. And remember that motion to the right is, and to the left is, of course, negative. Okay, so we're still sort of in the review phase here from grade 10, but we'll soon get out of that. So position and displacement. In order to illustrate the concepts of position and displacement, we're going to use a locomotive moving back and forth in front of a station as it shunts rail cars. Remember that the track is straight. Train station is our reference point, so we're going to label that with a zero. The train station is a reference point for analyzing the motion. As we stand at the station, we notice that the locomotive is 50 meters to our left. Sometime later, right in front of us, still later, 40 meters to our right, and later still 10 meters to our left again. We could draw a diagram to represent the various locations of the locomotive as measured from our reference point at the station. Now, oddly enough, you have these on here, but I don't. So x1 is where?
50 to left.
So that would be at minus 50, right? X2 is?
0.
Is it 0?
Yeah.
Yeah. Okay.
X3 is at 40.
40.
And negative 10 is x4.
Okay. Now, we use x for position. Okay, we use x for position. The x1 indicates the first position, x2 the second position, and so on. The line has marks on it which represent a changing position of 10 meters on each side. Since we need some way of indicating left and right, we use the positive and negative, remember? Right? And that should be sort of like second nature now for you. The first position, x1 of the locomotive, is shown as minus 50. This means that the locomotive was 50 meters to the left of the train station, our reference point. Similarly, x2 is 0, x3 is 40, and x4 is minus 10. Note the position is always measured from a reference point and always has a sign associated with it. Now, if we were to analyze the motion of this locomotive, we would need to know its change in position as it moves back and forth in front of the train station. Anytime there's a change in position, we say that it has undergone displacement. A change in position is referred to as a displacement. And I'm now going to give you a formula that you saw previously in the vector stuff, right? Displacement is a change in position. And if we want to determine any change in position, we use this formula here, which says displacement delta x, come on, go away. Displacement delta x is equal to xf minus xi, right? Now, we saw that when we did the vector stuff, Sam, right? xf minus xi. The symbol, the triangle thingy, the delta, is a much used symbol in physics. Is that my door? Might be. See anybody there, Logan? Sure. The symbol delta is a much used symbol in physics, which indicates a change in something and always subtracts the initial reading from the final. Always initial minus final. Right? The displacement of the locomotive for the first interval can be calculated delta x is x2 minus x1. So my f and my I have simply become 2 and 1. And I simply subtract, right? 0 minus minus 50 is plus 50. So between 1 and 2 is plus 50. In fact, if you go back and look here, right? Plus 50, from minus 50 to 0. 50 to the right. Not hard stuff at all. Okay, so my question to you is going to be, can you tell me what the interval, or what the displacement is between x2 and x3? With your clicker, please answer. Yeah, did you get a result right there? Oh, only 90%. What's the correct answer?
40.
Plus 40, right? Plus 40. Is it not from 0 to 40?
Yeah.
Is it not just 40 minus 0? Okay, try the next one, from 3 to 4. All right, so interval 3 from x3 to x4.
Oh, there. I put.
What's the value of x3? Is it 40? Is it not from 40 to minus 10?
Yep.
So your displacement is? Negative 50, yeah.
I put negative 50, but it says I got 0.
You put subtract 50, maybe.
There's no subtract.
Hello?
Can I redo it then? Because I got the right answer. Now it's gone.
I'm not recording it, Katie, so it's okay.
Now I got nothing on my screen. I can't do this anymore.
All right. So I would like you to. There's
nothing on my screen. I'm trying to.
There's several more displacement questions that are coming up. 1A is going to be number 1. 1B is going to be number 2. 1C is going to be number 3, and so on. Okay. So keep going. You can use the clickers, yeah, please do. Keep going until you get to number 10. Number 10 is a multiple choice.
Oh, join Bennett's class. What's my number?
Number 10 is a multiple choice. Alright, let's see how we did. So, from minus 8 to minus 2, 100%. The answer is 6. My,
I don't know what
100% right, it says. My grade 12s were telling me that last year we were doing one of these, and I got all excited because it was 100%, and then we realized that it was 100% wrong. See, I told you guys could do this. Almost 100% from 2 to minus 8 is?
Negative.
We're moving left, minus 10, right? From 0 to 8, moving to the right, 8.
Oh, man.
From minus 8 to 20, we're moving forward, positive 28. If you're doing the math, it would be 20 minus 8. From 8 to minus 8, we're moving to the left, minus 16. Okay, now the symbol delta can mean other things too. Now actually, well, you guys did really good on this here. So yeah, from 10 to minus 20, that is a delta C, a change of minus 30. Have you ever wondered, because like the triangle is like the Greek symbol, the Greek letter D, right? Yeah. Okay, so like what do Greek kids write when they're doing this? Do they go like this? Like delta D, is that like just triangle?
No, I think it's just one triangle.
You think so? Because like in North America, we write delta D, but their D is...
Does that really mean D?
Yeah. It's the Greek letter D.
It is probably just one triangle.
Maybe the triangle squared or something.
Oh, I think they do this.
You just said you need to explain it all over. You use the exact
If you're ever in Greece and you see someone that looks like they're in high school, you stop and ask them. Report back to me.
I'm never going to be done.
Hey? Well, they would have been in high school.
I'll get,
They would have known?
by then, my sister will maybe be in the class, so I'll get her to tell you.
Okay.
I got this one wrong.
Okay, now the only reason that most people get this one wrong is because it's actually 12 of 1750. It's really plus 5.50, I think, right? Yeah. It's okay, it's alright, don't freak out. If you lose weight, this is going to be
So I got 100%.
minus 5 kilos, right?
I would know.
All good?
Never mind.
Now this one here, this is, right, 20 meters above the ground into a hole 10 meters deep. So that is actually minus 10. So the math would be minus 10 minus 20 or minus 30 meters would be your
I
displacement.
got 100% on that.
Okay? And which ones are the same? Oh, we almost got everyone right. It's A and C, isn't it?
Yep.
You got it wrong.
Right? A and C. Okay, that's good. Alright, here's where things start to become not review anymore. Okay? So if you've sort of been on cruise control up to now, it's time to, click the cruise off, put your foot on the gas, and pay attention to the road. Alright, let's go. Knowing the position of an object tells us something about the motion of that object, but it would be helpful to know the length of time it takes to undergo the displacement. Displacement and time can both be illustrated at the same time on a position time graph. The position time graph is capable of providing us with information about displacement, average velocity, and instantaneous velocity. I'm going to pick on Miguel. Miguel, what's the difference between average velocity and instantaneous velocity? Can you help us out? What does that mean, Logan? Don't know? Okay. Yeah. And what's instant?
Just the one.
Single one?
Yeah,
Single one? Or a single event? And average would have to be over a
Period of time.
period of time. Okay, good. Good. Okay, so these three calculations will be performed using the sample position time graph shown below. So number one, displacement. Displacement is determined on a position time graph using the standard formula. Again, delta x equals xf minus xi. Now, the problem is that the x here is referring to the position, and the position is actually on the y-axis. Okay, so don't confuse that, right? The x is position, but it's not referring to the x-axis. It's referring to the position, which just happens to be on the y-axis. Okay, so don't get confused there. So the final and initial positions are located on the vertical coordinate, the y-axis. And if you desire, a dotted line can be drawn from the graph to the position coordinate in order to easily identify the two positions. In the example graph for time interval A is where it, like, from there to there, where it changes shape, right? And then B is from there to there, and then C is from there to there, and that's D, and that's E, and that's F. Does that make sense? Yep. Where the shape changes, then you need to watch. Okay? So what am I trying to say here? The displacement for interval A, where does it start off on interval A? It starts off at 0, and it goes to 6. It's actually just above Casey, I think. It goes to 6, which means our displacement is 6 minus 0, or 6, right? The displacement is 6. Now, is this thing moving up to 6?
No, right.
Why do you say right now?
Positive. Slope.
Right. And we're talking about train cars or whatever, things that just move?
Left to right.
Left to right, exactly. Rectilinear motion, right? Okay, so it's going from 0 to 6, a displacement of 6. So now your job is, you should have 5 questions.
So if it went the other way, it'd be a
It'd be negative, yeah. I want you to find the displacement for interval B, C, D, E, and F. B, C, D, E, and F.
I got 100%.
Let's see how we did. First one, correct answer is 0. The displacement is 0. The initial position is minus 6. The final position is also minus 6. Minus 6 to minus 6. Displacement is 0. Okay, Brett, I need you to unplug there, please. I knew you could do this.
Oh my goodness, Casey, I'm so proud of you.
Interval C.
Make it a 16.
Minus 16.
Oh, there's
right?
lots of different answers.
Minus 16. Yes, I see that.
I get like a
What's the final position? Minus 10. Way down here. Minus 10. What's the initial position? Plus 6. So it's minus 10, minus 6, minus 16.
next one 0.
D is also 0. How can you tell it's 0?
It's in a straight line.
Horizontal.
Not straight line,
So happy.
flat line. Sam, I need you to listen. Flat line. Okay, you need to know the difference between a flat line and a straight line. Flat line. 0. Okay? E is this little guy in here.
No.
It's an answer of 6.
That's another
Okay? 6.
question.
Final position is at minus 4. Initial position minus 10. So it's minus 4, subtract minus 10. This is when you need to listen, you guys. Because if you didn't get this right, you need to be paying attention. Because I'm going to assume you know what's going on after all this. Right? So that's a displacement of plus 6. The last interval, F, is from there to there. The final position is 0. The initial position is minus 4. So it's 0 minus 4 or plus 4. Okay? You need to be able to do those. You will see those on the test.
There's one more.
Gauge.
There's one more.
Excellent. 100%. That looks good. Why is this why can't this be a can't go backwards?
Unless you have a time.
It's not so much about going backwards in time.
Unless
Right?
you're Mr. Friesen.
It's more about being in the same place at 2 times. If I draw a line like this, right, and I go like that, at that time, at say 2.5 hours, where am I?
At 2 different places.
2 different places. Sam and Logan need to pay attention. Okay? How many people remember from math class the vertical line test? Have you ever heard of that?
Yep.
Kish, what is the vertical line test?
I remember that.
You remember?
I remember doing it.
Aurora, what's the vertical line test? Do you remember?
It looks soft.
Okay, hang on. Sam, I'm going to ask you to repeat this right away.
You draw a vertical line and if there's 2 points in one line, then it's
Not a function. Not a function. Is that what you were going to say, Mo? Not a function. No, I just want to point out that position and time has to be a function, because if it's not a function, then that means that you are in 2 places at the same time. So position is always
It's humanly impossible.
a function of time.
I'd stop there for lunch. I feel like this.
All right. I'm going to stop talking.